Hey science enthusiasts, today we're diving into some fascinating science shorts that will blow your mind. From the strange sounds of sirens to the invisible shield protecting us from the sun, we're covering it all. Get ready to explore the wonders of the Doppler effect, the ozone layer, microgravity, electricity, and even those massive space rocks we call asteroids. Let's get started. Have you ever noticed how the sound of a siren changes as it passes by? It's like magic, but it's actually science. It's called the Doppler effect. Sound travels in waves like ripples in a pond. When something that makes noise is moving towards you, like that ambulance, the sound waves get squished together. This makes the pitch of the sound higher. Think of it like squeezing a slinky. The coils get closer together. That's like the sound waves getting bunched up. Now as the ambulance passes and moves away from you, the sound waves stretch out, making the pitch lower. It's like letting the slinky relax the coils spread out again. This happens with any moving sound source, whether it's a car horn, a train whistle, or even a dog barking on a skateboard. The faster the sound source moves, the more noticeable the Doppler effect. So, the next time you hear a siren, remember the Doppler effect is at play, changing the pitch of the sound as it zooms past. Isn't science cool? High above us, way up in the stratosphere, there's an invisible shield protecting us from the sun's harmful rays. This shield is crucial for life on Earth, acting as a barrier that keeps us safe from the sun's more dangerous emissions. Without it, life as we know it would be drastically different, and not in a good way. It's called the ozone layer, and it's kind of like Earth's sunscreen. Just as sunscreen protects our skin from getting burned, the ozone layer protects all life on Earth from the sun's harmful ultraviolet radiation. The sun, as awesome as it is, emits ultraviolet UV radiation. This radiation is invisible to the naked eye, but its effects can be very visible and very harmful. Now, a little bit of UV radiation is okay, even good for us, helping our bodies produce vitamin D. Vitamin D is essential for healthy bones and immune function, and just a small amount of sunlight can help our bodies produce it. But too much UV radiation can be harmful, causing sunburns, eye damage, and even skin cancer. Prolonged exposure to UV rays can lead to premature aging of the skin and other serious health issues. That's where the ozone layer comes in. It acts as a protective shield, absorbing and scattering the majority of the sun's harmful UV radiation. Ozone is a special kind of oxygen molecule made up of 3 oxygen atoms instead of the usual 2. This unique structure allows it to absorb UV radiation effectively. This ozone layer acts like a sponge, absorbing most of the harmful UV radiation before it reaches us down here on Earth. Without this layer, the amount of UV radiation reaching the surface would be much higher, making it difficult for many forms of life to survive. Think of it like this. The sun is like a giant light bulb emitting all sorts of light, including the invisible UV rays. Just as a light bulb emits visible light that we can see, it also emits UV light that we can't see, but can feel the effects of. The ozone layer is like a pair of sunglasses, filtering out those harmful UV rays and letting the good light through. Just as sunglasses protect our eyes from the sun, the ozone layer protects the entire planet. Unfortunately, human activities have caused a hole in the ozone layer, but the good news is that with global cooperation, it's starting to recover. Efforts like the Montreal Protocol have been successful in reducing the use of ozone-depleting substances, leading to gradual healing of the ozone layer. So next time you put on sunscreen, remember the Earth has its own sunscreen too, the amazing ozone layer. It's a reminder of how interconnected we are with our planet and the importance of protecting it for future generations. Have you ever dreamed of floating in space, weightless and free? Imagine drifting effortlessly with no up or down, just the vast expanse of the cosmos around you. Well, astronauts aboard the International Space Station live that dream every day. They get to experience the wonders of space firsthand, from the breathtaking views of Earth to the endless starry skies. They experience something called microgravity. This unique condition allows them to float around the station, making their daily tasks both challenging and exciting. Now you might think space is a completely zero-gravity environment, but it's not quite that simple. The term microgravity means that there is still a tiny amount of gravity present. There's still a little bit of gravity even in orbit, but it's much weaker than what we feel here on Earth. This weak gravity is what allows astronauts to float and move around so freely. This microgravity environment makes things behave in fascinating ways. Objects that would normally fall to the ground on Earth simply drift and float. For example, Objects don't fall to the ground, they just float around. This can make simple tasks, like handling tools or equipment, quite tricky. Liquids form into perfect spheres instead of spreading out. This happens because without gravity, surface tension becomes the dominant force acting on the liquid, and astronauts can do amazing feats of strength like lifting heavy objects with just a finger. This is because the objects are not weighed down by gravity. Imagine trying to eat a snack in microgravity. Every bite and sip becomes an adventure. The food would float away. Astronauts have to be very careful and precise when eating to make sure their food doesn't drift off. That's why astronauts have to eat specially packaged food and drink liquids through straws. These measures help them manage their meals in the unique conditions of space. Living in microgravity can also have some strange effects on the human body. The lack of gravity means that the body doesn't have to work as hard to support itself. Without gravity pulling on their bones and muscles, astronauts can experience bone loss and muscle atrophy. This is why maintaining physical fitness is crucial for their health. That's why they have to exercise regularly in space to stay healthy. They use specialized equipment like treadmills and resistance bands to keep their bodies strong. So, while floating around in microgravity might sound like a lot of fun, it's also a unique environment with its own set of challenges. From eating to exercising, every aspect of life in space requires careful planning and adaptation. Electricity powers our world, from the lights in our homes to the phones in our pockets. It's an essential part of our daily lives, yet many of us take it for granted. But have you ever stopped to think about what electricity actually is? How does it work? Where does it come from? It's all about the flow of tiny particles called electrons. These electrons are part of the atoms that make up everything around us. Everything around us, from the air we breathe to our own bodies, is made up of atoms. Atoms are the building blocks of matter, and they are incredibly small. Atoms have a nucleus at their center which contains protons and neutrons, and whizzing around the nucleus are even tinier particles called electrons. These electrons are constantly in motion. Think of it like this. An atom is like a miniature solar system. The nucleus is like the sun, and the electrons are like the planets orbiting around it. This analogy helps us understand the structure of an atom. In some materials, like metals, the electrons are not tightly bound to the atoms. They can move freely. Now, in some materials, like metals, the electrons are loosely bound to the atoms and can easily move from one atom to another. This movement of electrons is what we call electricity. When these electrons start flowing in a particular direction, we get an electric current. It's like a river of electrons flowing through a wire. Just like water flows in a riverbed, electrons flow through a conductor. The faster the electrons flow, the stronger the electric current. This current can be harnessed to power various devices. It's like a river of electrons flowing through a wire. The faster the electrons flow, the stronger the electric current. This current can be harnessed to power various devices. We can use this flow of electrons to do all sorts of amazing things. From lighting up our homes to powering our gadgets, we can convert electrical energy into light, heat, sound, and even motion. This versatility makes electricity incredibly valuable. We can convert electrical energy into light, heat, sound, and even motion. So the next time you flip a light switch or charge your phone, remember the invisible world of electrons hard at work, making our modern lives possible. These tiny particles are the unsung heroes of our technological age. Remember the invisible world of electrons hard at work, making our modern lives possible. Without them, our world would be a very different place. So the next time you use any electrical device, take a moment to appreciate the incredible journey of electrons that makes it all possible. Out in the vastness of space, orbiting the sun alongside the planets, are billions of rocky objects called asteroids. They're like the leftovers from the formation of our solar system. Cosmic crumbs, if you will. Most asteroids are found in a region between Mars and Jupiter called the asteroid belt. They come in all shapes and sizes, from small pebbles to massive chunks of rock hundreds of miles wide. Imagine a giant cosmic shooting range with asteroids whizzing around. Thankfully, space is incredibly vast, and the chances of an asteroid hitting Earth are very slim. But it's not impossible. In fact, Earth has been hit by asteroids throughout its history, and some of these impacts have had dramatic consequences. Remember the dinosaurs? Scientists believe a massive asteroid impact wiped them out millions of years ago. Don't worry though, scientists are constantly monitoring the skies for potentially hazardous asteroids, and who knows, maybe one day we'll even mine asteroids for their valuable resources. So, the next time you gaze up at the stars, remember those rocky remnants of our solar system's past, the asteroids, silently cruising through the cosmos. Thanks for watching. If you enjoyed these science shorts, don't forget to like, subscribe, and hit the bell icon for more amazing science content. We've covered a lot of ground today, from the sounds of sirens to the secrets of electricity. Remember, science is everywhere, just waiting to be discovered. Keep asking questions, keep exploring, and most importantly, keep your sense of wonder alive. See you next time.